All right, I guess let's get started. So this is declarative refactoring for the masses. If you want, this QR code is for the slides, so you can sort of follow along, or click on any of the links that I'm not going to explicitly provide the URL for. So this is probably the most opaque title I've ever given, but here we are. My name is Andy. I'm the CTO at BrontoSource. We're this tiny startup that's focusing on reducing technical debt via automated migrations, specifically for C and C++. And we're hiring. So if you're interested in building developer tools and automated migrations, or you just think we have the cutest mascot, come find me after the talk. On the subject of the mascot, this is Charlotte. She is an adorable Brontosaurus. She was designed by my friend and artist, David Salagi, and he's incredible. He does other styles as well. Check out his stuff. He's really awesome. I would love to just have him work for us all the time, drawing these awesome things, but he has other things going on. So he's graciously allowed us to obviously use the artwork that we paid for, but also to generate AI images based on all of the stuff that he made for us. So you'll see that throughout the talk. The structure of this talk is mostly code and examples. There's going to be a bit of high-level discussion and background beforehand. Come on. But we'll see a lot of code. And please, questions as I go. If you have questions like, hey, what about this thing that you didn't present? Does it also work for this? The answer might be no, but I'd love to have those questions. Okay, so what are we talking about? Declarative refactoring for the masses. So let's define each of these terms. So declarative, I'm talking about declarative programming, right? This is a style of programming that focuses on what should be done rather than how it should be done. I've always found this pretty vague and ambiguous, but we'll try to narrow that down a little bit more. So refactoring, this one is probably reasonably familiar. It's often defined as modifying a program's implementation without changing any of its observable behavior. The problem is almost everything is observable somehow by someone, and Hiram's law tells us that if you have enough users, it will be observed and you won't be able to change it. So this is not a super useful definition. It's almost too narrow for allowing us to do anything. So I kind of want to just get rid of this, modifying a program's implementation, right? We might change some of the observable behavior, but hopefully we can get away with that. And for the masses, this is the part that is most important to me personally. Whatever we build, I really want it to be usable by any C++ engineer, not just the experts, right? I know we're all here at CPB now, we're all experts in this stuff, but I really want to focus on making things that are usable for junior developers as well. This is kind of the learning curve that I'm looking for, right? You should be able to run up the stairs here. It needs to be useful for beginners. I don't want there to be any extra knowledge required to use the tools, right? So maybe you have to read some documentation, that's fine, but you shouldn't have to understand how a compiler works in order to use these tools. And I want this slow reveal of complexity, right? Easy things should be easy, hard things should be possible, but I'm really focusing on making the easy things easy here. C++, both the language and the tooling, doesn't have a great history with this sort of thing. The learning curve for C++ looks a little bit more like this. And Bjarne said this, C++ has indeed become too expert-friendly. I remember him saying this at one of his keynotes in CPBCon, I think it was 2019. And as I was preparing this talk, I was looking up to find the first time he said this. And it wasn't 2019 when he thought that this language was too expert-friendly. It was 2006. So I want you to think about, in the last 19 years, how much easier the language has gotten to use for right? We didn't have at the time move semantics, lambdas, concepts, coroutines, modules. There are 4 different keywords that start with const, and only some of them produce a const object, right? This is not an easy language. And so I really want to focus on making this easy for junior developers. And that's why I think a declarative style is going to be useful for refactoring, right? Declarative is usually easier for people to ramp up on. So let's see what that looks like. There are a couple of really common examples that people point to when they talk about declarative languages, and we're gonna show some of those. So these are the kind of the guidelines that I think are really inherent to the declarative style. So first is unspecified control flow. And what I mean by that is you sort of declare what you want to happen, but not the how, right? Control flow is a very how thing. If you say, in order to achieve X, I first do A, then do B. That's the how. And a really solid example of this is regular expressions. Now, I know this is a terrible way to actually match dates and do date validation, right? This happily matches Febtober 71st, but bear with me on it, right? This regular expression doesn't actually say how to search for these things. And you might look at this and say, Andy, it says I'm going to match a digit, and then I'm going to maybe match another digit, and then a hyphen. But that's the ordering in the string we're looking for, not the order that we're looking for the things in the procedure, right? Any regular expression engine that's worth its salt will optimize this and search for things in potentially a different order, right? One useful thing it might do is actually first scan for hyphens. And if the hyphens are too far apart, well, then we just look for the next set of hyphens, right? This is a sort of Boyer-Moore approach to searching, but it says nothing about like the order that we do this algorithm in. Another thing that is really common in declarative styles that I think is important is the idea of just describing your constraints, your solution constraints, rather than how to achieve them. So here's another an SQL query that also looks for dates. And again, we're not describing the algorithm for looking for dates. We're just saying this is what we need when we're looking for a date. So declarative style has a huge number of benefits. Right? It's typically easier to reason about, and it's typically less error prone. Now, of course, we've all seen regular expressions that are just monsters and impossible to reason about. So it's not all the time, but at least for the easy cases, right? It tends to be easier to think about. I hate giving talks where I just list the benefits and that's it. Engineering is all about trade-offs, so there are some drawbacks to this approach. And implementation difficulty is often one. Computers are inherently procedural, right? And declarative languages are inherently not, so we need something to sort of close that gap, and that's what the implementation is. Right? You need a runtime or compiler or interpreter to translate the declarations into something that actually can run. There's always, I guess the idea is there's always a system underneath a declarative language that compiles or interprets a specification. Another drawback is these things often tend to be more restrictive, right? That can be actually they're less expressive languages in a sort of formal sense, or it can just be that in order to achieve the thing you want, you have to write something much more complicated. That's why we see these kind of ridiculous regular expressions sometimes. On the subject of SQL, I remember chatting with a senior director at Google a while ago. I was lamenting the fact that what I really needed in this moment was recursive SQL queries. And the particular engine I was using didn't have them. And so his response was, oh, well, no, you don't really need that. Just join the table with itself 50 times, and that's probably enough recursion depth that you'll be fine. Right? Like, yes, I guess that technically works, but this is sort of the restriction that I'm talking about. This is a quote from Alan Perlis. He was the first Turing Award winner. It says, when somebody says I want a programming language in which I only need to say what I wish done, give them a lollipop. And then there's this follow-on quote from Matt. I hope one day to have a quote that good. Right? So he's saying that like it's almost impossible to get something that's just like purely declarative. Like this is a fool's errand or just a child's dream. I want to point out here, if you search for Perlisisms or you click on that link, you will find some amazing quotes that Alan Perlis has had over the years. It's just a joy to read. There's like 140 of them. So, okay, that's declarative programming. How is this going to apply to refactoring? So here's sort of the desired features that I'm looking for. Refactoring is all about the find and then the replace, right? I'm looking for something and I'm going to change it. And so I want to describe what I'm looking for, but not like the precise algorithm for how to find it. I want to describe what to replace it with, but not how to do all of the text munging specifically. That should be handled by the system underneath. Because I care about the for the masses aspect of this, right, this description language needs to be incredibly intuitive. And I know, because I know the kinds of problems that I'm thinking about, that I'm going to need access to C++'s type system. and I'm going to need access to the preprocessor so we can actually handle things like macros. So there's an obvious choice for a tool here, right? Clang Tidy. And Clang Tidy is a fantastic tool. How many of you have used Clang Tidy at all? Okay, like almost everyone. How many of you have written or attempted to write your own Clang Tidy? A good number of people. Awesome. For those that haven't, or for those that still need help remembering all of the wacky commands, Kristen's talk from CPBCon 2023, absolutely fantastic. I've been doing this for 5 or 6 years. I still reference this talk. Clang Tidy has a ton of amazing benefits, right? If you're just using it, there's like close to 400 checks that are available that will tell you useful things about your code. A little bit over half of them have fixes, so you can just mash a button and your code gets better. It's free, right? And I mean this in both senses of the word, in the sense of you don't have to pay for it, but also the licensing is very permissive. And you can write your own checks. So these are all the wonderful things. I have personally found a bunch of pain points with using Clang Tidy, though. Distribution of a Clang Tidy check can be tricky. You typically upstream them into the LLVM project, which means that if you're working on something where you have like a proprietary, the code you're looking for is proprietary, you probably don't want to put that in an open source project. It's possible to maintain your own, but it's trickier. Maintenance can be a little bit of a pain. The benefit of Clang Tidy is you get access to everything about the AST, but it's unstable, right? And the API does, in practice, actually change over time. And so you have to kind of keep up with that. But the real kicker here is that Clang AST matchers are just complicated. They're really difficult to write correctly. So most of the audience has attempted to write these, so bear with me as we go through sort of thing, but let's try to match string concatenation, right? So if you're new to this and you look through the documentation, you find binary operator. That's what I'm looking for, right? Operator plus. And I want it to be operator plus, not just any binary operator. And I want to be a little bit more specific, right? Not any operator plus. It has to be ones that match strings. So I have to say something about the left-hand side and the right-hand side. And I'm going to say that they're expressions that have some type. And that type should be a CXX record decal whose name is std_string. CXX record decal is Clang's way of saying a class or a struct, right? So not so bad to write, but 0 matches found, right? This will find nothing in any code, I promise, ever. How many people see problems with this that they happen to know? Okay, a few, but not as many people have written Clang Tidies, right? So that's interesting. So the first thing is that binary operator is specifically for primitive types. It is not for operators that you've overloaded. Obviously, what you needed was a CXX operator call expression. The next thing that doesn't work is we haven't handled CVREF qualifiers, right? The things that get passed into operator plus for string aren't strings, they're const string references, right? And you have to be explicit about this. So we need to add this thing where we sort of get rid of the qualification. So we add this unqualified desugared type. And on top of that, std_string is not a class. It's actually an alias for std basic string of char at the appropriate allocator and char traits, right? So it's not going to match a CXX record decal. What we actually need here, obviously, is a record type that has a declaration that's a class template specialization whose name is std basic string. So the problem here is that Clang's implementation details really matter, right? You have to understand those in order to make these matchers work. The language details all have to be handled explicitly. And if you're not somebody that's already familiar with these distinctions of reference qualifiers, that's a real pain. And the standard library details matter, right? If I say I want to match std_string, I shouldn't have to care whether or not that's an alias, right? It's just a type. I should be able to match it easily. And that's not sort of out of the box with Clang Tidy. Right? This is not really the learning curve I'm looking for. But okay, it's 2025. We have AI. It's awesome. Like maybe we don't need to understand this. Maybe we just get AI to do the heavy lifting. It generates the matchers. We check that they're right, and then great, go on our day. So I tried this, and I gave a prompt to a bunch of different LLMs write a Clang tidy matcher, or write a Clang AST matcher that matches string concatenation, and then just provide the matcher and no other text, because I wanted to be able to like copy exactly what it said and not the explanation of why the thing was correct. So let's take a look at what some of these did. So this is what DeepSeek gave us. Binary operator, so we know that that's already not correct. Has operator name, and these left-hand side and right-hand side, is any character. What does this match?
Characters. It doesn't exist.
It doesn't exist, because characters aren't addable, right? They get promoted, integral promotion to integers, and then they're added. So this actually matches nothing. Not even, nowhere near strings. Okay, llama 4, we have the binary operator problem. It manages to ignore something about implicit casts, but you have to match var decals, whose type is const char star. You can't really add those. This is not going to work. Claude, binary operator problem again. This manages to figure out we want basic string instead of string, but still binary operator. Still we have the CVREF qualifier problem. And subtly, as string is different than has name in a way that makes this, also this won't match anything. Perplexity was perplexing. Here we have a string literal, unless its parent is a string literal. String literals are leaves in the AST. They don't have children. So this actually won't even compile as a matcher. Sorry, it will compile as a matcher. It certainly won't match anything. Gemini 2.5 was the closest to getting anything right. It did get CXX operator call expression, but we still have the problem of this CXX record decal. So I tested this with a bunch more LLMs, right? And I decided, I'm not going to show them all to you, but I made this table that we can summarize the results. So the first column here is whether or not it was correct, whether or not it actually matched the thing I wanted. And the second column is, did it match anything? Is there some C++ code that you could write that this would match? And the summary of the results is... Now, to be fair, right, I didn't try to run this and then talk to it and give it, tell it, hey, no, you should have done this. But if you're a junior developer and you don't know how any of this stuff works, you're not even going to know what to tell it, right? So this is not perfect. Worse than that, these two didn't, they weren't valid matchers. It wouldn't compile at all. So yeah, that's fun. So that's the find side of things, right? What about the replace? So for source transformation, Clang tooling is a little bit better. It's actually much better. What I really would want from it, though, is to be able to modify the AST, right? To say, if I have a binary operator and I maybe want to swap the two arguments, I want to just do that by moving some pointers around. And that's actually technically allowed. But in order to get that right and keep the AST sort of correct so that you can do future modifications properly, it's really hard, right? If I were to just move these two things, that might be a different operator that's chosen. And that might involve a template instantiation. And you have to track all of these things in order to have it be correct. You could maybe settle for not complete correctness, but I'm kind of aiming at a high bar of correctness here if I'm already using compiler tools. So that's not great. In terms of the rewriting aspect, Clang Transformer is reasonably easy to use. And thanks to Yitzi, somewhere back there, for building this. This is, I think, reasonably easy to read and understand what's going on. But we have this wonderful problem of Clang doesn't store the location of a semicolon in its statements, which means if you need to go and modify something and possibly remove a semicolon, you have to play this wonderful game of where's the semicolon. Yeah.
So one question about getting the AST, just modifying it, swapping arguments around. So to get the correct behavior, you have to run SEMA again on semantic analysis on what you get to get a valid AST out of that, right?
But I also need to handcraft the types for the expressions I've changed, right?
Sure, but the problem is if you skip that step, if you don't care about SEMA at all when you do those kinds of transformations, how do you guarantee you end up with a valid program, right? You can't, right?
Sure. Yeah, I think that's why it's difficult. Yeah. So this is my favorite game to play, right? Where's the semicolon? I had a lot of fun generating this image, getting it to generate something in the style of Where's Waldo, and to put a semicolon in there that was hiding. The outtakes on this were absolutely hilarious. There were some were just like giant semicolon in the middle of the screen. It was like very obvious, but this was a lot of fun. So yeah, so source transformation may be a little bit better, but still not ideal. Right? And like, so this just doesn't really cut it for, it might work for experts, but it doesn't really cut it for making this really easy to use. But what if we took a more declarative approach? Right? What if we just annotated our regular code with the intent of a refactoring, like what we wanted to change? So here's an example of that approach. This might feel a little bit unmotivated, but hopefully by the end, you'll see why this is a really powerful technique. So inlining functions. What I mean here is kind of what the compiler does in terms of optimizing, but doing it at the textual level, right? So throughout a bunch of these slides, you're going to see a definition on the left, usage on the right, and we're going to do an inlining and see what happens. So in this case, we have this make widget function that is just a wrap around make unique, and maybe I want to inline that. And what the inlining looks like is we add this attribute that declares our intent of we would like to inline this. We would like this function to be inlined, and then we have a system that inlines it. And there's a couple things I want to point out here. One is the extent to which this is very textual, right? When we did the inlining, we actually included the comment, which is not generally part of the AST. So that's intentional, right? If you didn't want the comment to be moved, then you just remove the comment before you tell it to inline. The other thing is that it's a little bit more than textual, right? If we just sort of purely did a textual replacement, we would get operator precedence wrong in this case, right? So we had to add the parentheses around num type A gadgets and num type B gadgets in order to keep this correct. If we were inlining into a different namespace, right, we might need to qualify a bunch of the function calls with namespace qualifiers, and that's also handled by this system. So you might be familiar with Maslow's hammer, right? It is tempting. This is he's talking about the cognitive bias. It is tempting if the only tool you have is a hammer to treat everything as if it were a nail. But here's the thing. In this case, really, everything is an inlining. And okay, not actually everything, but way more than you might expect. So let's talk about using inlining to do function renames, right? So I've got this old function. I want to rename it to new function. So what I'm going to do is first I'm going to set up my definition so that the inlining does the right thing. And I'm going to re-implement old function to just return a call to new function. It can be in a new namespace, doesn't matter, right? This is going to be purely semantically equivalent. And then we add Dr. inline. I didn't mention, I guess, the DR is for declarative refactoring as a namespace I'm sort of using for this whole talk. But then I get to say Dr. inline as well, which is fun. So we add this attribute to the function, and then the system will do the inlining. And if you think about what happens when you inline this function, well, it's just going to rename the function everywhere, right? So I don't have to go manually do find replace, like with Vim macros or whatever, or sed, and possibly update things that I didn't want because it got the wrong overload. I just run this tool on all of my code, and I have renamed all the functions.
Well, comments pointing to the function maybe.
So this won't rename, like if a comment references references the function, like that might not work. You can do things like, if you've properly marked it with backticks in the function, we can find that and parse that and rename it. But then if it's part of an overload set, you run these problems. So again, like none of these tools are going to be 100% perfect, but this at least gets you like 99.9% of the way. Yeah.
Just to clarify, this is like one file transformation. So one of the biggest pains is to apply this at scale.
Yeah.
At least for us. So you'd have to do something on top of this to do a scale application.
So if the definition of the function that you're inlining is visible in the header, then it's actually in every translation unit. So it will actually work across all of these.
So I'm wondering if this inlining at that level can subtly cause changes in the behavior of the program, right? For example, if you have an implicit move on the return expression, on the return statement, right?
Yeah, so there's a whole bunch of details that I'm intentionally glossing over here. You have things like when does the destructor of the argument run, right? If there's an implicit conversion first, are you changing the types inside? So these are all things that that we handle. We try to make it as close to what a developer would really type. Like if there's an implicit conversion from int to double, but int looks fine, we might do that. But this is all going to be configurable, and we do try to address all of those. Yeah, Dave.
So I mean, typically, it's one of C++'s great flaws, I believe, is that it really cares about where destructors run, and mostly programmers don't care. So shouldn't the default be to do nothing and let it happen where it happens?
Yeah. So right now the default for the tool, if you put a string in there, we're not going to like try to explicitly delete the string afterwards. If somebody were to do something wild like pass in a mutex lock, we want to handle those sorts of things where it like really matters. But by default, we for destructors, we just kind of like, yeah, that looks like a regular type. That can just happen at the end. We don't have to add extra curly braces. We're done.
Just a comment, not a question regarding these questions. It's this is why also coding styles matters, and you shouldn't write tricky code, because then your tools have a hard time trying to understand what they're doing.
This is true.
And the people.
Yes, and the people. Yeah, that's absolutely right. The flip side of that is there's a ton of tricky code out there, and we do want to handle it mostly correctly, right?
Also, the tricky code is the one that needs refactoring.
Yes, the tricky code is the one that needs refactoring. Super true. Yeah, so this is inlining to do a function renaming. And when you're done with that, the old function isn't used anymore. You can just delete it. And what's interesting here is all of the manual work you had to do happened on the left-hand side, right? That's important. Okay, so that's renaming a function. What if we want to remove a default argument? Well, what we can do here is split our function definition into an overload set, where the null array function is going to call the unary function and give it the default. And then that's the function we're going to inline. When we inline it, the call on line 1 is going to be replaced. The call on line 2, it's not the function we're inlining, so it just stays as it is. And then when we're done, we delete the function, and we've exactly inlined the default value, and we've removed setting the default in the function there. Changing return type. This one is a little bit trickier, right? You can't just do this with overload sets the way we did on the last slide. But what we can do is we can start by doing a renaming, right? So sort of move this name out of the way for our purposes. So what we do is we change the name via the same process to get untyped user ID. We inline that. We get rid of the renaming inlining. And now we can do our replacement. And so what we're going to do here is we are going to change the function to what we want, to have this strong return type of a user ID. And we re-implement get untyped user ID to call get user ID, and then immediately unwrap it and get the raw value out. So when we inline this, we push this strong type into all of the user code. Now it's not perfect, right? Because we haven't actually done anything super valuable here. Get user ID is present, but we immediately discard this thing, and we're back at an int64. But this at least moves the strong type towards all of the usage code. And we're going to come back to how you fix things like this, right? Inlining won't solve this problem because inlining will never change a declaration, but we'll have other tools that will change declarations. On a similar note to changing a return type, yes, and then you delete the inline function at the end. On a similar note to change the return type, we might want to introduce recoverable fallibility, right? If you have an interval class like this that maybe does the check if the lower is greater than the upper bound, and it aborts. The problem is at the usage site, you might not know if those values satisfy that property, and if you don't want to abort, you want to do something else, you're going to need to check it, and then it will be checked again during construction. And so we want a way to sort of push these checks closer together so that we can eventually collapse them. So what do we do here? Typically, this is done with a factory function. And that's what we're going to do. We're going to add a factory function. This could be stood expected, but I didn't want to have to write the error type as well. So stood optional here. And we return nullot in the case where the lower bound is greater than the upper bound. Otherwise, we construct a thing. Once we have this, we can re-implement our constructor in terms of this factory function, right? And we do the same thing we did previously, where we call the factory function and we immediately ask for its value, right? This is going to have the same semantics. It will abort in the event that the lower bound is greater than the upper bound. But now we have a constructor that we can inline. We add the inlining attribute, and we look at the usage, and we get something like this. Now, if you don't like auto here, if you'd rather this be an interval, this is all configurable, right? This is probably how I would spell it because we already have interval here, but how it precisely gets inlined is configurable in the tool. Murda, did you have a question? No, okay. And then when you're done, you can remove the original constructor so that nobody's going to opt into that again. So we can sort of evolve our code and close the door behind us and make sure that the things that we didn't like disappear. And this is the common refrain I get, right? Like, my IDE can do this. Yeah.
I'm sorry. Can you go back one slide?
Sure.
I'm really missing something about this example because all it looks like you ended up changing ultimately is people are now calling the factory function syntax instead of constructor syntax, which seems like a downside. So I'm obviously missing something.
Yeah, so the important thing here is that make is returning an optional. And this has the same problem of the return type as before, but we have at least pushed the optionality towards all of the user code.
Okay.
And then we'll have future tools that are going to be able to modify this so that,
Got it.
Yeah,
Thanks.
cool. All right, so this is the common refrain I got. Like, yeah, my IDE can do renames. Like, what's the point? And honestly, if you can use an IDE for these things, like, I'm not here to sell you on a tool that does something you already have a tool for. That's not the point. But there are a lot of places where an IDE actually isn't sufficient. If you work on a really massive code base where the code base does not fit in your IDE, then you need another tool, right? If you are a library developer and you can't see all of the code of all of your users, well, at least now you can describe your intent and they can run the tool and fix all of their code, right? That separation is sort of not possible when you're working within an IDE. And like, even if this does all fit in an IDE, you might not want to stop what you're doing, like run that tool and like, okay, I'm going to put that away and I'm going to then work on like doing this refactoring, and you have this massive yak shave. I kind of want to just set it up and forget about it and let a tool in the background do all of the work, and then I can remove the function at the end. But it sort of parallelizes the work of the refactoring and the thing you actually care about. Yeah.
To clarify, when you run your tool, this doctor inline, the function that was marked up inline is not actually removed.
It's not removed. That's right. So what we don't have, but I would like to have at some point, is something that does whole program analysis, sees that that function is never invoked once the inlining has occurred, and then it also automatically gets removed. But at the moment, inlining just says, we're going to keep this function here, and we're going to burn down the callers. Yeah.
The other thing is your IDE doesn't run during your continuous integration pass. So, and a lot of people like that. They want to see on their pull request, oh, this is the thing you should have written. That code you just wrote, it should be spelled this way. Right.
Yeah. So you can also use this as a way to educate developers, right? So when they see it in a pull request, they'll know like,
Or it's
hey,
also to stay ahead of the problem, so you can actually.
you can also stay. Yeah, you can also stay ahead of the problem.
At a certain scale, someone's always breaking the thing a little bit more, and so you have to stay ahead of them.
Yeah, it's a really good point. So, okay, I gave you examples of functions and constructors, but inlining is a little bit more general than that, right? If you think about what inlining really means, sort of boiling it down to its essence, we have an entity that's named, and we have a definition for it. And everywhere it's referenced, we replace it with its definition, right? And there are lots of named entities in C++, not just functions and constructors. Type aliases are a name, and you can do inlining on them, right? So you can rename types this way, and you can do all of this is very analogous to functions, just sort of at the type level. Yeah.
So that one would be very nice for me, but the problem is in some places it will be an alias, in some places it will not be an alias, right?
So old type name needs to always be an alias for this to work.
No, I mean old type name is, but they will pass it into a function, and that function will spell out the specific thing.
Yes.
Then you need to replace that function as well.
Right. So it'll still compile, right? Because they're the same type. Because it's an alias, but the replacement does need to happen everywhere, and that's what the tool does. Did that answer the question?
Maybe. Thank you.
Okay. So you can do this with types. You can do this with macros. You need to spell it a little bit differently because you can't just add an attribute on a macro. But you could do inlining for macros in the same way. Namespaces. I actually really hate this spelling. If people have ideas on something better here. For some reason, namespace aliases can't have attributes on them. Someone who understands why, I'd love to know. And I hate this spelling because it says inline namespace, which means something entirely different in the language. But here we are. And then the one that I think is really cool is entire headers. Right? This is also a named entity, the name of your file. And the include is the use of that file. And so you can, if you inline a header, you're saying like, I would like to replace the contents of this file, like right where you included it. And this might seem like a totally nonsense thing to do until you remember that you're in charge of what's in the header that you're inlining. And so if you want to rename a file, you can sort of have your header forward to the header that you actually want it to have the name of by just having a single include. And then the inlining is a rename of your file, a rename of the includes across your entire code base. So, and there's a bunch more named entities here that you could do, right? So there's a demo of this available on Compiler Explorer. We so far have only implemented this for function inlining and type inlining. The others are a work in progress, and we'll put them up as they become ready. But yeah, so this is inlining as a technique for refactoring. And I want to spend just a minute talking about why this actually works, why this is powerful at sort of a theoretical level. Like I've seen this work in practice, but there's a little bit of theory that kind of explains this. And the idea is there are really two sources of complexity when you're doing refactoring. There's local complexity, and this is what I mean of somehow this is inherent to the change you're trying to make, right? Complexity that like I'm trying to do a complex thing and that's it. And then there's the network complexity aspects of, this is the, life would be great developing a library if it weren't for all the users, right? This is the all the users aspect of it. So just some examples of where things fit on this graph so you get an understanding of what I mean by these. Formatting a file is pretty low on both of these. It's not that hard to format a file. You just mash the Clang format button. And while that does, that scales, where I might have to modify a bunch of different files, they don't interact with each other in any meaningful way. And so I can inline them separately, I can format them separately. I don't have to worry about weird interactions. If I have to optimize a function, right, that has pretty big local complexity. That's a hard problem. But I'm only touching the body of the function, right? All of the callers ought to just work normally. Now, Hiram tells us that that's not actually going to happen, but for the most part, you can get away with, when you're optimizing a function, you don't have to worry about all of the callers of that function. If I have to rename a private method, well, renaming is generally pretty easy, and private means it probably doesn't have that many callers. But there's some trickiness there. It's not so bad because I don't have to worry about overload resolution too much. That's simpler for method calls. But if I'm renaming a public function, I have to rename all the call sites. And I have to worry about ADL. If the thing I'm renaming comes from an overload set, I need to make sure I'm just renaming that one overload. And if I'm renaming it into another overload set, I need to make sure that I'm not affecting overload resolution in that new overload set for all the other calls, except in the ways I actually intended to. Right? So this gets really subtle, and that's all from network complexity. And if you have to rename the signature, if you have to change the signature of a virtual function, you are in a world of pain, right? You have to look at all of the overrides of your virtual function and understand how you should adapt them to the particular signature change that you're looking for. And then you need to go and update all of the colors of all of those overrides. Right? This has just a ton of complexity in here as things scale. The best lesson I ever learned in refactoring is that whenever possible, you need to separate the network complexity aspects from the local complexity. Don't attempt to handle these at the same time. You're going to have a bad day. And this is what inlining does, right? Inlining does not address any of the local complexity. It addresses all of the network complexity, right? It handles that you have to set up your function or your type to be inlined appropriately. That's where the local complexity lives. And then you slap on the inlining attribute, and it handles the network complexity for you. Do you remember Sean's keynote from Monday? He said, all problems of scale become a network problem. And I swear to you, I made that slide and I called it network complexity before Monday. So let's talk about the situations where inlining doesn't work. Right? We mentioned there's a bunch of cases we can't change declarations. You might not have a function that can be inlined. You might not be able to patch somebody else's code for a function that you want to inline. And here we're going to take a lesson out of Java Refaster. So this is developed by Louis Wasserman, former coworker of mine and good friend. So the idea here is you write a class and you add these attributes on some methods in the class, and these are supposed to describe patterns of what you're looking for. Right? So in this first one, lines 3 to 5, we're looking for some object of type string. We call that has dot equals called on it, where you've passed in an empty string literal. Right? So typically what you'll see here is this will be a function with exactly one return, and then the thing that's being returned is the pattern we're looking for. Right? On the second line, you see the same idea. We're looking for dot length equals 0. And that string can be anything. And we describe that by having it as a parameter to the function. And so you describe this as a parameter to function. You should think of this like capture groups in regex, right? We're sort of capturing whatever that string expression is and calling it S. So yeah, I should have tabbed through these, but this is what we're matching. This is where we describe the captures, and then we annotate it. It's just saying, this is what I'm looking for. That's where we describe the intent. And then afterwards, we also use a pattern to say what we're going to replace it with. Right? This should feel very similar to a tool like sed, but instead of doing it for just strings, you have a little bit more structure here. So we can imagine what this might have looked like if we had it in C++. And it basically carries over, right? We'll have another struct. We'll have these attributes before and after that we attach these things, and we can do these replacements. So let's go back to the string concatenation example that all of our LLMs failed on. This is what we might write here. So the idea here is we're looking for concatenation of strings, and we're going to replace it with Abseil stircat. Right? So we have this before function. We're looking for left-hand side plus right-hand side. They both have to be strings. And we can see there's actually a bunch of those in this. Now, what we actually have here, I guess, is a string literal that will be implicitly converted to a string. And this is sort of all handled by the pattern, right? These patterns are intended to be a little bit more syntactic, so I don't have to worry about all of the implicit conversions. But there's a cool thing we can do with C++. I don't have to necessarily match just a string. I can match anything that satisfies a concept. And the power of this is that any concept will do. If you have really complicated things that you want to match, well, you can put your own concept in there. Right? And you can constrain this with, you can run arbitrary context per code to figure out if the type is the thing you want. In this case, it's, we can just use ones from the standard, but you might have really complicated things, and that power is available to you, but it's not required of you. So when we run something like this, we get a transformation that's not ideal. Right? We've replaced every operator plus with stircat, and you might, as a sort of newbie to these tools, you might run this and not be happy, but at least it's clear what happened, right? we matched every single plus and we replaced it with stircat that many times. And so what you do next is actually relatively easy to figure out, right? How do we fix this problem? Well, we could add another rule that goes and looks for nested calls to stircat, right? And so here we have this, we're looking for stircat where the first argument is stircat with any number of args. I actually don't care anything about the types, so I'm not going to bother saying anything about them. And then I'm going to replace it without the nested calls here. And when we run that, all of the nested calls disappear. Yeah, see?
In practice, do you run the tool until the fixed point, or you just like let it sort of like each time you run the tool get one bit deeper? So
this depends on what you want your code base to look like, right? There are some of these things that like they compose really nicely, but the intermediate states might not be something you want to show to a developer. And for those things, you might want to run to fixed point. There are others where it might be like too tricky to do that, especially things like cross-translation unit boundaries. So this is whoever's running the tool gets to answer that question for their particular use case. Okay, so we replaced things with stircat, and then we got rid of we flattened all of the nesting. We could have done, oh yeah, sorry.
In order for this to work, do I need to include the transformation into the stircat header file?
Not necessarily the stircat header file. It needs to be visible in any translation unit that you want the thing to run on.
So into the string header file?
Or like some other header file that is broadly used. Now, these are things that I would love, right? If this got widely adopted, I would love this sort of thing to just sit inside of Abseil's stircat header. Because this is a useful optimization for anybody that typed this or another transformation that generated it. And they could just keep it there, and anybody running the tool would have. Right? This is having a library owner describe the intent of how this thing should be used. But it might not happen yet. Yeah, Braden.
So these rewrite expressions, is this something that's meant to be checked into your source? Or is
Yes.
It something, oh, really?
Yes. We could set it up in such a way that you keep it off to the side. But the idea of checking it into the source is that you're describing this is the first time I've seen something where you're sort of describing the direction you want your code base to go as part of your code base. And we've set this up to be like incredibly cheap at compile time, like very like negligible to actually have, because you'll never instantiate one of these. Yeah.
So how does the tool check, or does the tool even check that it produced a valid transformation?
The tool does not check, but you can compile the code again and determine that. We could have that as part of the tool, but then you have two compilation steps, and so yeah.
Does it need to be visible in the same translation unit?
Yeah, so I've gone back and forth on this, and if you want, so for the simpler examples, like this one, there's no reason it should need to be, right? You could sort of build out the change that you want to make and describe it, and then run that on any translation unit. But when you start doing things like this, I'm not gonna sort of build up an entire transformation that might run arbitrary context per code in order to compute these, whether or not these concepts match. So for things like this, I think it does need to be in there.
I think you'd also have edge cases where different translation units had different ideas about what's convertible to what, for example.
Yeah. That's a really good point. Okay, so we went through all of this. So there's another way we could have done this. I do think that having the flattening is generally useful, but we could have gone straight rather than having two separate steps here, because we can use variatics, right? We can have a fold expression that represents the addition of arbitrarily many of these things convertible to strings, and replace that with stircat, right? So we get to use fold expressions to represent sort of the like clean star in regex. So there's one more thing that I want to do here, and it relies on the fact that Abseil stircat actually natively handles integers, right? It will print them in decimal. And so I don't need that stud2 string there. Now, there's no inlining technique that's going to fix this because stud2 string is generally useful, just not if it's nested inside of strcat. Right? There's no specific function we can inline to fix this problem, but we can write one of these rewrite rules. So if we look at this, right, the thing we're looking for on line 58 is strcat with some number of things on the left, then toString of some number of things on the right. I've elided all of the types here. I'm pretty sure you can really get away with not mentioning any of the types, but you can add the types if you want to make this more precise. And then, of course, the rewrite that we use here is just we remove stud2 string. Yeah.
I don't think this is valid C++, is it? Like Adix on the left.
Yeah. So in fact, I found that mistake in this example. You'll notice I moved like auto right hand side and the args so that worked. Yeah, having two packs here, this is not going to work. So we'll have to find a way to express this differently. I'll have to think about that. But yeah, there surely is a way to describe like toString somewhere in there. So yeah, thank you. This is obviously slideware, and a lot of these are. So as I mentioned, the inlining is actually like we have that. It works. It's available as a demo. Some of this stuff we've done, but we haven't implemented the variadics. So you're seeing things that I have not actually totally verified yet.
That compiles as C++ or?
This ought to, except for the issue that you have.
In terms of the use of the tool.
Yes.
You place it in somewhere where the compiler actually tries to compile it.
Yes.
But then it's never get invoked except by your tool. So.
That's right. And you can, if you want to, right, you can throw this in an if-def that like will only our tool will even see it.
When you scan it, you use standard C++ to compile it?
Yes, yeah.
And then you look at the AST to figure out what it meant.
Yep, that's exactly right. Yeah.
So about fold expressions then, if this is what you do. Fold expression is a very different AST from just the plus.
Yes.
How would that operate?
So we're not taking precisely the AST and doing a matching against like the precise AST that you would see at the pattern. We're using the fold expression node to represent an arbitrary number of operator pluses. So like we have to do that transformation.
So that's a DSL that looks like C++.
Yes, that's exactly right. DSL that looks like C++.
Okay.
Yeah.
Does this replace all of the two-string occurrences within the same expression, or just one?
That is a good question. So what I think would happen here is if there's multiple toStrings, this will match multiple times, and it will generate multiple patches. And they will, depending on how we generate the patches, they might conflict with each other, right? And if we did, we would pick one of them, and you could rerun the tool and run it a second time. There are cases where they don't conflict. If we were careful about sort of surgically removing the toString and the closing parentheses, we could get them so that they didn't overlap and they would all happen together. But in the general case, you might have conflicts, and we just pick one. We're done.
I don't recall if you went over this or not, but do you deal with references, const references, and that kind of thing?
I didn't mention that. This is honestly somewhere where I'm not sure what the right thing to do is. Right? If we think about making this really easy for junior developers, I kind of want to neglect that and have it just work, but I don't know what just work means. I think it would be, if you spell it without const references, then anything goes. Like we'll match const references or R values or anything like that. If you added const reference, we might only match those, but yeah, I sort of don't know.
Assuming you have rewrite expressions that are meant to be run in sequence, does your system here allow for the specification of like one must go before the other, so you're not wasting resources?
It does not, but I'm certainly open to adding that. I think, yeah, right now it's just you would just run the tool again, and compilation might be expensive, but hopefully this is running at night when nobody's looking at it. Yeah. Right, so we run this one and the toString disappears. Right? So I also took this approach and I asked some AI how it goes. And I gave it a longer prompt because, this API doesn't exist, right? So I need to explain a little bit about the API, but I try not to give it a really precise formal definition here because I wanted a relatively fair comparison against Clang. So this is all I gave it. And the important thing is sort of at the end, I asked rewrite string concatenation into Abseil stircat. Reasonably vague about what I mean by string concatenation. And we run it, and so I asked ChatGPT, and we got this, which is correct. First try, right? And so then I asked the follow-up question of, okay, so do it for arbitrarily many strings. And I got this. It guessed that the fold expression was correct, right? This is super cool, right? I didn't tell it that I handle variatics or templates or anything like that, and it just sort of guessed correctly. I did try this on a few other LLMs, and they weren't all perfect. A common mistake was because in the description I said that dr before was an attribute, it said, oh, that probably needs to be in double square brackets. But if you got code like that from an LLM and it added these extra brackets, and you've seen at least one example of this before, you know exactly how to fix that, right? It's sort of an easier problem for a human to fix than going through Clang AST matchers. And this is really the learning curve that I'm looking for, right? I want it to be really easy for developers who have some experience, but maybe not even a ton with C++. They're relying on AI to help them here. So I think the key point with this is that because this is modeled after like C++, right? Because the DSL looks like C++, much more of the training data for LLMs is actually applicable. And so it's able to generate things much more accurately than it would if it was a bespoke API like AST matchers. And what's interesting here is that like this familiarity is not just useful for AI, but also for humans, right? Humans are likely able to guess what the correct thing they want here is.
I see you're inheriting off a rewrite expert.
Yes.
What's that about?
That is just a way to tell the tool that this struct is a rewrite expert, like this is where you should be looking for these things.
Tag in it?
You just put a tag. I'll show you the definition of rewrite expert later, but it's an empty struct that just deletes the default constructor. Like just nobody is ever going to instantiate this thing. Yeah.
Well, what about types? Or
what about types? So I don't have any examples for types here, but you could do a similar thing, like with a before and after aliases inside. So yeah, there's all of the same things you can do with inlining, you can set up with this sort of framework as well, with some effort. I haven't thought about how to do macros or something like that, but yeah.
Is there a way to turn this off? Like if I have a specific instance where I'm like, no, I really do want plus.
Yeah. So the typical way you do this with Clang tooling is to add a nolint. Depending on the cases, like those nolents can get really verbose. So I don't know of a way that we would describe this where basically the way I would think about this is adding a nolent in the cases that you want. And if there are a lot of those, well, then probably you wrote the rewrite rule wrong, right? It probably has too many false positives. We're done?
You could probably have a macro that wraps around something that says don't like refactor this.
Yeah, you could also wrap it in a macro or something that we could provide. I don't love any of those answers.
We kind of need ISO papers about how to annotate stuff like that.
Yeah. Yeah, I guess attributes you could add to a bunch of expressions as well, right? Okay, so this was rewriting expressions, and I promised you that we would have a way to rewrite declarations as well. And this is kind of what that looks like. So I'm gonna sort of slowly build up a matcher here that's gonna match variables that probably represent durations of time, right? And I wanna specifically distinguish between something that's a duration versus a point in time. I'm using the Abseil time library because I'm more familiar with it and it's a little bit easier than std chrono, but all of this should carry over. So if we look at this, where we have the rewrite decl, which is a way we describe that, hey, you're looking for a declaration as opposed to an expression. And this is saying we're looking to match a declaration of a variable of type int32 under t that should be initialized with literal 0. And we look on the right-hand side and we see things that are initialized with literal 0. We see things that are in 32T, but none of them actually match, right? So this will not find anything. If we're looking for something with any initializer, well, we use the parameters as the sort of capture groups that we described before, and this will match another value. Notably, we don't actually care about the spelling of the declaration on the left-hand side, right? V can be anything here. If we don't care whether or not it's initialized, we just don't say anything about its initialization, right? So this is also going to match the function parameter. And here's a place where I'm actually not totally sure about this particular API, because what if you want to say, I care specifically about default initialization? So we have other syntax for that I'm not going to show here. I don't know whether or not this is the correct trade-off, but I'm trying to focus on like what would a developer who doesn't know that much about the details of the language expect this to match. And I think this is probably right. All right, if we want to match any declaration with any initializer, like we don't care about the type, well, we'll use auto for that. Right? So this will match all of these things, but not the function parameter because it doesn't have an initializer. If we want to constrain this a little bit more, we can add a concept, right? Just concept constrain what we're matching. And if we wanted to have the information about which type it matched so that we could use that when we do the replacement, well, we just give that a name and pull it out into a template parameter. Right? And there's one more thing that I need to do here. If I'm looking for things that match durations but not points in time, right? You can see that probably this thing called dir under seconds represents a duration, but definitely the thing that I've assigned to with time 0 is a point in time. I need to be able to distinguish these, and we'll get to that. But the first thing I want to say is these things that say under seconds in them are probably relevant, right? As opposed to another value that's just an integer. And so I need to be able to I need a way to look at the names of variables. And C++ today doesn't really give me a way to do that in sort of standard C++. So what we do is we have some functions that will allow you to look at the variable name, and it will return a string view, and you can just check, does it end in seconds? And we just require that has to be true. So this is syntax. These are functions that are sort of stubs in your code. They don't actually do anything because obviously you can't look at the variable name with standard C++. But when you run the tool, we'll evaluate this as we compile it. Yeah, see.
Are those little require statements like that extensible? Like, could you write your own if you needed?
So the require is like that's sort of hard coded. It accepts any bool that can be evaluated at const expert time. And then you put any function you want in there, right? Any expression that you want that can be evaluated. Does that?
Okay. Well, I'm saying for Dr. Variable name, like let's say you wanted to like get the template parameter pack from a variable or something like that, and you wanted to require something about that. Could you write your own little bit of code, like you could like a rewrite rule? Yeah. So if it's something that you can sort of extract out in standard C++, anything works in there. For other things like getting the name of a variable here, we will need to provide some of these hooks. In the future, all of these hooks will be available with reflection, right? And so we won't need variable name like further into the future because we'll have a DSL that we can rely on of reflection here. But for the time being, we've got to provide these because also when you're doing refactoring, you're not aiming at the latest and greatest version of C++. I want this to work for things that go back far in time if you need to. So yeah. So okay. So we've got that, and we run this transformation, and we just replace it with this Abseil duration. We use the same variable, and we wrap it in Abseil seconds, right? Because this thing represents some number of seconds. Yeah.
You mentioned using the template parameter on the before so that you can also use that type in the after.
Yes.
How does that look?
So that would look like replacement would also be a function template, and it would be templated on T, and uses of T would be whatever the type was in the before template.
So you need to manually specify that they require the same concepts and. That's what.
They don't have to match the same concepts because we're not actually instantiating any of this code. So just type name T would work just fine here. But you would need, if you want to refer to T, you would need to have those things match. Yeah, Dave?
Does this matcher gloss over the mess of initialization syntaxes?
Yes. Initialization syntax is also a very hard problem I am intentionally glossing over for this talk. I don't know what I want to do for all of it. I have some ideas, but like, if you're interested, talk to me afterwards and we can figure out what makes sense here. Yeah.
If I want to make sure that both are the same template argument, can I pull out the template parameter to the decal?
Pull out the template parameter to the decal.
So make it a template struct.
That's interesting.
Possibly. I think
it wouldn't be deducible by the function. Or no?
Yeah, I mean, we would be able to parse that and build a matcher. I'm trying to think about what semantics make sense there, and I don't exactly know. Just adding the template parameter on replacement would be sufficient to make sure that like they're the same type, because you're only invoking the replacement when you have a template parameter for.
Do you match the names of the template parameter?
We will match the order that they're called in rather than the names. And we will probably give you a warning if you chose names that didn't match. The reason that we're doing it based on order rather than the naming is because when you have variatics, you can't always put them in the right order that you would want. So, yeah.
I just wanted to follow up on David's earlier question about initialization. So would this catch if on the right hand side I had like a curly bracket initialization or parens initialization? Would that catch that?
Yeah, as I'm currently thinking about it, this would match any of those. I'm not positive that's right. I'm like honestly 50-50 on it. But we will come up with something. Like we'll do the research and ask a bunch of junior developers what they think makes sense, and we'll come up with something that's consistent and also makes sense to them. Yeah.
So this makes sense to me. But what might also make sense is just to have an attribute, double brackets, dr, : requires, variable name, ends with underscore seconds, right?
Putting it directly on, rather than wrapping it in the functions.
On the declaration. Is there some reason you prefer this kind of thing versus leaning into the attribute system more?
So where, like, if I just put the attribute on the declaration.
Then you don't have to say it's a declaration because it's already.
Oh, you're saying instead of inheriting from rewrite decal, that's part of the attribute.
You have to say it's that V because you put it on that V, right? You can put it.
I see. Sense? And then you could put more of these in.
And you can put all kinds of attributes on there if you need to.
Yeah. Honestly, I hadn't thought about that.
Talking about an attribute on the first method.
On line 5, yeah.
Yeah, that might work fine.
Okay, so no reason it's just okay.
Yeah,
right.
I definitely don't want these to be members of the struct because the things you're allowed to put there change, right? So, and even this doesn't cover a lot of the cases you might have for declarations.
I don't actually see why there'd be any improvement in putting that expression in an attribute. You're just increasing the levels of nesting and characters. Like
there'll be less characters though. If you're
two square brackets, why?
No, you wouldn't need all the extra association logic to say it's the thing I just talked about. You just put it right on the thing.
You mean the name V?
Yeah.
Because you would say the name V, and then in the replacement
you still
using
have to
V.
say variable name.
You might not even need to say like you just say the name ends with whatever, and that would be the obvious thing you'd be talking about.
Oh, putting that all in the attribute?
Yeah.
In the attribute on
you
V.
put all kinds of things in an attribute.
Yeah.
So one of the things that doesn't let you do is make requirements that cross different expressions that are inside of Declan.
Well, he's already matching names and stuff, so you can do that too. You can just put capital T in there if that's relevant, right?
Yeah, I think you're missing.
So I'm not sure. I do want to move on. I'd love to continue talking about this. I am open to all sorts of changes on the syntax here, right?
Sure.
But Murdad, did you have a question?
Same thing. I was just going to say if you have requirements on multiple variables, this lets you express it.
Yeah. And right now we do only support one variable, but yeah.
Just to clarify, what kind of state is this working right now? So you can type this and at least some examples will work.
So no one can type this because we haven't put it up on Godbold yet. But I can type. So we handle expressions and some very basic declarations. I started building this about a month ago. Okay, so right, this is what the replacement looks like. This definitely has some mistakes, but it's this is if you just wrote this is what you would get. So we probably also want to change the variable names here, right? If you have a duration, we don't want it to be called dir under seconds anymore because it's a duration independent of that particular unit scale. And so we need a way to describe how we're going to change the name of a variable. And the little hack that we've come up with is to add this type alias, which will always expand to void, but you can shove in a function here that's evaluable at const expert time that takes a string view and spits out a string view. And we call that to with the variable name to change that.
The replacement of the value auto init, is that the same like semi-textual thing you're doing before with inline?
Yeah.
Okay.
Yeah, that's right. So we have this strip seconds, and it will change the names of all the things that it matched. Now, there's still a bunch of problems with this, right? And we have a little bit of a network problem here. I've changed the type of duration. The function is still returning in 64. And so I need to address that. Rather than trying to deal with this local complexity at the same time of the network complexity of, like, I'm going to change the function call and then all the callers, and like this is going to be a huge pain. We're just going to first get more space on the slide, and then we're going to add this usage after function. So anywhere the variable is used, we will basically inline this function around it, right? So we're going to convert this back to in 64 seconds. And when we do that, we get this, right? So we've converted it back. On the line above where we call set deadline, we have this little ugly thing, seconds of 2 and 64 seconds of the duration. We can write another rewrite rule that's going to address those, right? We've moved the declaration problem into the expression space, and we know how to deal with expressions. Yeah, okay, I should have found it. So we can deal with that with another rule, as I just mentioned. And there's one more problem that I see here, which is this thing, right? We matched too much in this case, right? We didn't want to wrap time zero of this. And so what we need to do is make our matching a little bit more specific, right? We only want to match these declarations if we find some usage of the declaration that has a property that we like. And the way we express that is we say, well, the usage before, somewhere that variable had to be wrapped in Abseil seconds. That's how we know that this represents a duration and not just an arbitrary time point, right? And if we have that, this duration of time, where time seconds is initialized with time zero, won't match anymore, and we will only change the things that we actually wanted to. Right? So there's a bunch of techniques here for changing declarations. Hiram Wright gave a talk on similar ideas where he sort of painstakingly wrote. Yeah.
Did you show how the strip seconds look like?
So strip seconds is I didn't show it just out of the saving space on the slides. This would be a const expert function from string view to string view. Mm-hmm. It takes in the name of the variable beforehand, and it returns the name of the variable afterwards. Okay. And obviously, you could put arbitrary stuff in there, right? Yeah. So Hiram gave a talk on this in 2019 called Time Travel, about sort of propagating these stronger types for time across the code base. He did this really painstakingly over, I think, a couple of years, writing the Clang tidies to do all of these matches. A handful of them are available publicly as part of the LLVM project in Clang tidy. A handful of them they've never made it out of Google. But it took him a lot of work, and he's very good at this, right? So I guess really the main takeaway I want you to have from this particular slide is Charlotte in the TARDIS. That's the important thing here. Yeah.
When you do the rewriting, you do it yourself, or do you write it to a rule for Clang tidy?
The rewriting we do ourselves. There's enough subtlety there that it was easier to actually just do that ourselves. In terms of how the tool works internally, we build up a Clang AST matcher from the specification that you see, though.
So you mentioned like the internal AST specification changes. How sensitive are you then to changes like that?
We are very sensitive as Clang is unstable and it changes, right? But it's just us. It's not all of the users of these things.
So you're tied to like specific Clang versions.
We would be tied to an explicit Clang version, but because I care a lot about migrations and moving forwards, I will make sure it works with the newest version as soon as it's available. Just because I'm a weird person that cares about that. Yeah. See.
If you have a refactor rule that has to work different across different versions of the language, do you just use a macro to like?
Yep.
Okay.
Like if C++ like is whatever. Yeah. So yeah.
What about classes that are compiled with more C++ than one C++ version? Is there a way to say like?
Sorry, say that again.
Well, like a lot of files are compiled with all the versions, like standard headers, right?
Yeah. So if you need to compile with a ton of different versions, you probably want the rewrite to. Maybe you can run with a rewrite rule on a newer version, so you can use the variadic templates or whatever in terms of the rewrite. But you would probably want to make sure that the output is valid in the oldest language version.
Do you have the problem of because you want the rewrites to be visible in the same translation unit, though, right?
So you would wrap it in a if-def that checks the version.
Well, I was more thinking like the matches would is convertible to and things like that would be like you have differences, right?
You would have you mean the semantics of those,
the
or
standard library has more constructors because
maybe
it's too exotic to keep talking about this.
No, it's an interesting point, and one I hadn't thought of. You probably then wouldn't want to run that on a different version than where you're generating it for. So you might be restricted to using things that you can write with like 03 or whatever version you're on.
Depending on the rule, it might be good enough to get a note that, hey, this is a thing some human needs to go look at and move on or something.
Yeah.
I don't know, maybe you'll still talk about this, but this is very cute and I like it. But generally speaking, for me, writing a replacement for any one of those using clunkTidy in a simple case would take probably a day or two.
Sure.
My main pain points will come from distributing this to go run across all of the files and apply all the changes and review all of the changes and all of that stuff.
Right.
Any ideas about that?
Yes, that is an entirely separate talk. But like, how do you actually run this across an entire code base or many repositories and things like that? Different talk, and I have some thoughts about how that should be done.
That's really cool.
So the tool looks useful, but I have concerns with the proposed use case. So it seems to me like from the architecture of the tool, there's not much that we can do to ensure that those transformations preserve the semantics of the program, right? If you have like junior developers, they're like vibe coding these transformations, it seems like that could introduce subtle bugs, right? That might not be a problem for a massive company like Google, but like in code bases that are more under-tested,
Yeah, so so you hit on an important point. Having tests for this stuff, and not just this, for any code that anyone writes, vital, right? Like you really want to have good tests for these things. Inlining is going to be semantically equivalent. Like that's the goal. For the pattern rewrites, it might not be, and that's actually by design, right? You might want to make changes that have some small semantic differences, test that they're correct, and then submit them.
Even inlining, right? So some of the behavior that I said, like for example, implicit move, that has changed multiple times across C++ standard versions, right?
Yeah.
And different compilers can have different behaviors, like maybe your rewrite word for Clang, if person then compiles that rewrite with GCC, gets an issue as well, right?
I think the main point here is C++ is really complicated, right? And like what I'm aiming at is very high bars of correctness. I am not going to achieve 100%. And if you write your own Clang AST matchers, you aren't either. right? No one is going to get 100% on this. This
And
is
if you
all.
do the refactor manually at scale.
Yeah.
Definitely not.
Yes, thank you, Dave. If you're doing this by hand, it's going to be at least as bad, right?
You're not, well, I'm sorry.
Yeah, sorry, we're done.
I just want to say, like, you should still review the code that gets like generated, and like as if anybody wrote it. This is not something that's meant to be like just the whole code base gets refactored without you looking at it. It is, you can, once you get the hang of like what kinds of things go wrong, then you can probably review faster and know what to look at.
I do hope we can get the review of these sorts of common things to be faster than a human like looking at every single line. But again, that's another talk.
So now we're just in the discussion. Sorry, I don't have a question. But the idea being that you could get this into a library, right? Like Abseil for Abseil cat, right? Or stircat rather. You get that in the library experts who understand the semantics of the behavior can write the rewrite rules rather than little Timmy who read the docs one time and is now like the question is like, are the semantics correct? I trust the Abseil authors more than I trust Timmy, is I guess my point.
Timmy is a great developer, but he does make mistakes.
Yeah, exactly.
And like conversely, you might be a user of Abseil and know that you're trying to like there's specific applications for you. Like, there's both cases,
right?
Like I need my team is using Abseil the wrong way. But like the problem can't be generalized to the point that the Abseil authors could put that rewrite in there.
Yeah.
Right.
Dave,
I think it's also possible. I mean, it's obviously not in this tool, but I think it's possible to write static analyzers that would list semantic differences or possible semantic differences. And
yeah. That's certainly not in the tool, but that is a thing that you could do.
Yeah. Thing that you can do.
These last two, and then I want to finish the slides, and then we can continue talking.
Let's finish them first.
All right, sure. So I do want to show one more example that I think kind of ties everything together. So I have basically the same thing we just looked at, where we're replacing int64s with durations. It's a slightly simpler example, but here we go, right? I'm looking for any int64. It needs to be wrapped in Abseil seconds in some usage site. And we go and we try to do this refactoring, and we have this problem, right? We would match this. I can't change the type of int64 of the duration seconds because that has the network effects of going to like all the callers of this function. But this is where the real power of just declaring what you intend to do rather than doing it comes out, right? Because we know how to specify that we want to change the type of a parameter to a function, right? We do that with our hammer inlining, right? So this rewrite rule will say, like I see that there's a this int64 that you want to change as a parameter. I can't do that today, but I can set up your code to do that in the future, right? And then this inlining will go and run, and it will make all of those replacements. And then we have this other rule that does the annihilation of seconds in 2 and 64 seconds and cleans up code otherwise. And you've made these changes actually spread across the code base. So this is kind of the power of this approach. I promised I would show you the header. So this is the entirety of the header that you would have to include, right? There's nothing ends up getting instantiated in your code. So there's no runtime cost at all here. There's exceedingly negligible compile time cost, right? So this is, you can set this up if you really wanted to, like throw that in if-def so it only is visible within our tool. But for the most part, this should just sort of work. Yeah.
Are you talking about a doctor no that just tells you no?
Very nice. So DR is also
that's how you signal static error.
This is also just the namespace for the slides. We're using a different one, but I wanted something short enough that I could include it properly on the slides without making. Yes.
So, do you have like testing tools testing tools for the rewrites?
To test that the rewrites are like semantically equivalent?
No, that I wrote the correct thing. I want a unit test my rewriter.
Yeah, if you wrote a rewrite and you did not provide any before state, we would catch that and let you know. If your inlining is not something that's inlineable, we would let you know.
No, I want to write unit tests for my rewriter.
He wants to.
Ah.
Okay.
I see now. Yeah, so we'd probably have a separate binary that you could like give the before and afters and test that they are the things you want. Haven't written it yet, but yes, we will.
It's not too hard to wire that up to something like C-test, or I'm sure there's something similar, but I would imagine that would be popular if there was something.
For sure, you definitely want that. Yeah. So this is kind of what I'm envisioning, right? I want to handle all of the network complexity of things completely automated. I want to do this like codifying of best practices, right? I want these things for Abseil StoreCat to live next to Abseil StoreCat. And so you can provide, as a library developer, you can provide intent about like where your library is going to your users. And honestly, I just really want software evolution to be easy, and this looks like a thing that we can do to get there. So yeah, that's the talk. Dave.
So fantastic talk. And
Thank you.
I love this work. I love the way you address questions here too. Clearly there's some prior art here in Java Refaster.
Yeah.
Can you sort of explain where this advances the state of the art over existing tools? And
yeah. So my understanding of Java Refaster is that it only works at the expression level, right? So you don't have rewrites of declarations. Java also has an inliner that works. They're particularly focused on semantic correctness, and so they won't inline things that like swap the order of parameters in a function because that might change the order of evaluation of things. But as far as I know, there aren't tools like this in any other language.
And this is C++, so we're okay with things more dangerous like semantic correctness.
Semantic correctness.
I just want to point out how important it is to be able to compile your code base with Clang. Like, if that is not a project that's on your timeline and you can't already compile the code base with Clang, you're missing out on a lot of tools that are already there and will be coming. So like that is something to consider putting on your timeline. And it might be easier than it sounds because you don't have to link or embed any resources or anything. It's just parsing that you need to get going to get a lot of these tools.
And there are some things like Clang is generally pretty good at compiling things that are compilable with GCC. Slightly worse for like MSVC extensions. But we also don't need to like completely parse. Clang will say like, hey, I don't know what to do in that corner here, but I'm just going to continue anyway. And in those situations, like, yeah, you might miss out on some refactorings. There might be some false positives, but it's generally still usable. See.
The refactorings, are they text-based when you actually produce them, or are you actually doing AST swaps then? The
replacements are text-based with the caveat that all the places where it can't be text-based, it's not.
Yeah. What if the code you want to replace is generated by a macro?
If the code you want to replace is generated by a macro, we are not going to replace inside the macro, probably. I have some thoughts on how to do replacements inside macro if I can kind of parse what's inside the macro well enough, but that is a research problem at this point.
This is also why you should not use macros unless you really need to.
Given that, why aren't you using attributes syntax instead of the macros?
Why not attribute syntax instead of the macros? Attribute syntax, there are a lot of compilers that by default warn on, I don't know what this attribute is, right?
I think it's all of them.
So like this is really annoying because that's not an attribute that's part of the standard, and I would like to use it. And so like under the hood, I think I showed was just like the under annotate, under attribute with annotate, so that it sort of works broadly. I have no problem with the attribute syntax if it was not going to cause these annoyances though.
So the status currently, you said it's something on Godbolt, some stuff on the development.
Yeah, so the inliner for functions and types is available to play around with on Godbolt. The other stuff is pretty early days. So we'll put demos up as soon as we can, but it's going to be a little bit.
Is that going to be open source?
It's probably not going to be open source immediately. We have to think about like the right way to handle all of that.
Business case.
So we have.
It's not a dirty word. I want to make money.
Right now I am making $0. I would like to start making money. There are lots of models that make this compatible with open source. We have to figure out what we're going to do there.
What was the last question? I lost my train of thought.
Last question was.
Was it open source?
No, no before that. Oh, it has to be syntax.
Yeah.
Couldn't you just strip out the warning flags and turn them off?
When we run the tool,
Oh,
yes,
that's right. Okay.
but not when you're compiling.
You can make a macro that expands. Use a macro inside the attribute that expands to nothing when you're not the compiler understands it.
Does anyone know any Clang developers that can fix this?
Probably none at this conference whatsoever. Yeah, we're done.
And also, I think underscore attribute, like, it can go in some places that brackets can't. I don't know if you have any of those cases in here, but like that might be another reason to have a macro.
I have not found any of those cases. I would definitely not want to rely on that behavior in case we want to change it at some point. But, yeah. All right, I think we're about at time. So find me afterwards. Let's talk. I'd love to hear your ideas.
Appreciate that.